Rob Ressler again. Hey, so here's the solution to the challenge. The challenge was to make an ocean maker, and so we did this. At least it's sort of ocean maker. I don't know what ocean you've been to. And as always, we typically like to start with our demi template from our it's not open. So it's from our examples. Go to the dummy template, open it up, copy everything. So select it all, copy, and paste it to a new sketch. Okay, and really simply, I'm gonna replace a lot of this. You create a noise generator, which in Pd4P3 is your noise class. And I'm going to use both two filters to make this work. I'm going to use the bandpass filter, and just to stick with pure data conventions, what Miller-Puckett came up with was called BP in pure data, but it's a bandpass filter. So I just like to use the same terminology as PD. And in PD, the low pass is called LOP. It's better than the slew low pass, which is called SLOP. So at least you're not a slop, you're just a LOP. All right, and then we're going to need a couple of variables. So we're just going to need a frequency. So we'll call it, for now, cutoff frequency. Just cutoff, and we'll just set it to 0. Well, we'll set it to 100, just so we have something. And then we're going to use the bandwidth, and we'll set that just to 1. And so the bandwidth is typically for band pass, so it's how many frequencies it lets pass through. So the thinner the bandwidth, which would be a larger number in this case, the less frequencies are going to get through, and the bigger the bandwidth, which would be a smaller number. It's counterintuitive, I know, but it fits pure data's schematic. It would be wider. So it's typically called the Q. So we're actually going to call it that. So we're going to have two getters and setters. So we're going to have a set cutoff and a get cutoff. And we'll just change dummy to cutoff. Oh yeah, I did step case. I won't do it for that. Okay, and then we're going to have two getter setters for the Q. So we're going to have a set Q and get Q. All right, so those set and get our Q. Make sure that we free everything. So we have a noise, we have a bandpass, and we have a low pass. There we go. So we have to set those while we're running our algorithm. So we're going to do a bp.set center frequency, and we're just going to put inside of it get cutoff. And oops, that is a function. And we're actually going to use the same cutoff frequency, but scale it up for the low pass. So it's the cutoff is actually the center frequency, but we're just calling it the cutoff. And in the low pass, it actually is called the cutoff get off. Cut off. There we go. And we're just going to scale it. I think in my example, I scaled it by 700. So it means I just added 700 to it. So now this BP center frequency, which is creates that kind of whistling sound, is going to be our cutoff frequency, and then our actual cutoff on our low pass is going to be the cutoff plus 700. And then we're going to have the final bit here is going to be set the for the bandwidth, we're going to set Q wait, there we go. Okay, so now we're gonna just play it, make sure it works. Oh yeah, it's not going to do anything because what? We didn't do anything. Everything's just set to 0. So first off, we're going to start with noise. And noise doesn't do anything other than just performs. Okay. But now we need to filter that noise. So how do we do that? Well, you could make a new variable such as like double noise. No, that's not a good idea. N equals noise.perform, right? And then you could make another variable called double I don't know, L. So we low pass noise. So lop.perform N, right? And then you could do the last one we're going to do is the band pass. So we would band pass dot perform L, and then just send it out there. So we're kind of like chaining through variables. You could do it that way, and let's see what we get. Yeah, so we get basically noise, filtered noise. That's one way to do it. But you can also do it this way. So we have noise.perform, and then we can put that inside of our argument to the low pass by just putting it inside the parentheses. And yeah, you can keep going. You can do bp.perform and put it inside of parentheses. So it looks a little confusing, but if you kind of know what you're looking at, you're filtering the low pass filter of the noise. So it kind of goes from inside out, and we should get the same result. Yeah. All right. Well, that's pretty easy. So now let's just set it up here. So we're going to need two floats, center frequency, and our Q. And we're going to use our mouse. So center frequency is equal to, we're going to use that map function. So it's going to be mouse, we'll have X as our map, our value. And it should go from 0 to width, so the width of the screen. And we'll have our center frequency, or just our cutoff slash center frequency will go from, what did I set? 40? Okay, 40 to 500. So the ocean's not that noisy. And then we're going to set it. So remember our music class, right? Our music object now it's called. We're going to set cutoff CF. So that references that setter. And we'll do the same with Q. We're going to map it to the Y, mouse Y, and the width and the height. Sorry. And Q should go, I think we can go in decimals. We'll go like 0.1 to 10. And so, yeah, well, we should save it. Why don't we save it now? We'll call it the ocean, spell ocean. There we go. And we have to set it in our object. So set Q to Q, save and play. All right, so now you can set the Q based on your height starts to sound a little more whistly, more wind-like down here. And that's right. And you remember that X and Y are flipped. Sorry, Y goes like top down, not X and Y are flipped. I don't know why I said that. So if you actually want it to go from low to high, you gotta flip them, because it goes from 0 to height downward. So it's just how I've been told processing draws the screen from this way to this way. So it's just gonna slightly counterintuitive to how we think as audio people. And there we go. A makeshift ocean maker. And so maybe you did something even cooler than that, which wouldn't be hard. But it's just 3 classes. And we just kind of interleave them, and we just set their subsequent parameters as we need to using getters and setters, and we free them as mandatory. And then we just use the same mechanic that we've been using in the processing side, which is mapping using the mouse and the width and height of the window. And you have yourself your basic wind machine / ocean maker. If you made something even cooler, I'd love to see it. You can email me through the GitHub, or just send it through this video. I don't know. You'll find me. Thanks for watching.